We all know that Hyperledger Fabric works as an umbrella project under Hyperledger. In this session, we will discuss Hyperledger Fabric architecture and how it is implemented. In this diagram, we will assume that the flow is set up and running. A client has registered and enrolled himself with the certificate authority of the organization. In the application, the user is authenticated and receives encrypted content, which is used to authenticate him to the network. Now, a transaction proposal is created that contains a request to invoke the chain code. SDK is then used by calling one of the available APIs to create a cryptographic credential to develop a unique signature and send it to endorsing peers with the help of channels. The endorsing peers confirm that the transaction proposal is well-formed, unique, and the signature is verified by using membership service provider. The client is adequately authorized to implement the operation on the channel. At this point, no updates are made to the ledger. A set value is passed back to the application layer with the signatures of endorsing peers and read-write sets for the state of blockchain. The application then confirms the signatures of endorsing peers and verifies it with the transactional proposals that were sent and received. Now, if the chain code queries only the ledger, the application will verify the response and not submit it to ordering service. If the client directly submits it to ordering service, the application would cross-verify with endorsement policy whether it has been fulfilled before submitting, in which case it means the client has been endorsed. The architecture is designed in such a way that if the application does not verify and forwards it without being endorsed, it will be enforced by peers at validation phase. The application then broadcasts the transaction proposal and responses within the ordering services, and ordering services does not need to inspect the content in the proposal. It just needs to arrange them as per the channels. After that, the blocks are delivered to the peers in the channel, and the transactions in the channel are set as valid or invalid according to the endorsement policy. A notification is then sent to the client application that the transaction has been appended to the chain. Let's understand simple chain code execution flow. The first component is application (SDK), or you can use any programming language, for example the Node.js, to retract and submit the proposal. The transaction proposals are submitted by an application to the endorsing peers. The purpose of the endorsing peer is to execute the chain code to simulate the proposal in the peer, query state DB, and build a read-write set. Their target is to endorse the transactions and structure them according to the executions. After the proposal submission, the endorsement policy outlines how many or what kind of combinations are required to sign a proposal. The endorser actually executes the chain code to simulate proposal in the network and create a read-write set, which is done on a local basis. Once it is completed, the endorsing peers sends the signed proposal back to application SDK. Then the application submits the transaction and the signature to the ordering services, after it is received in the form of transactions on the read-writes from the virtual machine on the blockchain or the state machine. The ordering services create a batch of transactions and deliver them to the committing peers. And when the committing peers receive the batch from ordering services, then each transaction is validated through the committing peers on an individual basis. Finally, when the committing peers receive all the batches of the transaction, it will validate with the endorsement policy sent by the endorsing peers, whether they are correct or not. Moreover, they ratify if read-write sets have any conflicts or not. If there are any conflicts, the committing peers will reject the transaction. If both validations are passed, then the block is committed to the ledger and the state updates from each transaction and is reflected in a state database. Once it is done, the complete ledger will be updated to all the peers in the blockchain through committing peers. So, that's how the whole transaction and flow works. The main constituents here are endorsing peers, ordering services, and committing peers. These are the three set of policies or set of peers called endorser, orderer, and committers. We will discuss them in detail in upcoming sessions. As you can see, this figure here illustrates the Hyperledger Fabric architecture, which helps you to understand the complete Hyperledger Fabric. The architecture is aligned into three different categories, namely membership, blockchain, and chain code. These structures are a logical structure, not a physical depiction of partitioning of components into separate processes, address space, or any virtual machines. In Hyperledger architecture, some structures are built from the bottom up, some use open source technology, whereas some interface with the existing services to fulfill the required functionality. Let us begin with understanding services first. The membership manages the identity, privacy, and confidentiality of the network by participating into verification of the public and private key. The participants register to obtain the identities which enable attribution or the authority to issue security. In this case, the security is issued through the security keys for transaction, so whenever the registration is happening, certificates are issued back to the entity, node, members, and users, which they can use to validate the transactions. There is also a reputation manager who manages the auditor to view the transactions of the participants, assuming that each auditor has been granted proper access to the authority by the participants. Technically, what happens is this membership services helps in auditability of the whole blockchain, not just the identity manager and the registration. Now, moving on to the blockchain services, which manage the distributed ledger through peer-to-peer protocol, which is built on the HTTP protocol. The data structure is optimized to provide efficient schemes for maintaining the word state replicated for many participants. They ensure that all the blockchain ledger is being replicated to all the participants in an efficient way. The different consensus algorithm ensures there is a strong consistency, which is plugged in or configured as per the deployments. So if you want to change the consensus manager or P2P protocol, you can always do that. The chain code services are secure and lightweight to send the chain code execution on validating code without affecting the other nodes. The environment is locked down and secured in an independent container with a set of signed base images which contain the secure environments, the chain code language, the SDK image for Go language, Java as per the requirement, and the Node.js as well. An additional programming language may be enabled in the future if required. So this helps you to run a chain code in an independent container, and it does not affect the other application. After this, we move to membership services. Hyperledger is a private validator network protocol. All entities are required to register their membership services to obtain an identity with an access and transaction authority on the network. A validator during the network setup can determine the level of permission that is required to transact. Network setup also defines the network as a permissive, allowing ease of access, which could be rapid, the high adoption, or restricted to a more controlled environment. So, registration services offer the control and management of authorization of Hyperledger participation. Identity management also provides management of assurance and authorized exploring of association of identities and roles for Hyperledger participants. On the other hand, the auditability service offers the capability to provide entities with a means to link the transaction of individual users or groups of users according to the affiliation roles and to access the activity of the particular user of the system or the operation of the system itself for better security and management. This is so because the administrative authority might want to audit the accessibility of data as per their security policy. We have talked about this earlier too, that blockchain services contains 3 to 4 significant components, like P2P protocol, distributed ledger, and consensus manager. The P2P protocol actually uses Google RPC, which is implemented over HTTP2 standards. So it provides many functions, including bidirectional streaming, flow control, and multiplexing request over a single connection. So most importantly, it works with an existing inter-network infrastructure, including firewalls, proxies, and security. This component actually defines the messages used by peer nodes from point to multicast, and the distributed ledger manages the blockchain and the world state by implementing the 3 key attributes. These are efficiently calculating cryptographic hashes of the entire dataset after each block, transmitting minimal data of changes to the datasets when a peer is out of sync and needs to catch up, and minimizing the amount of data stored, so that it requires less space for each peer to operate. This is the responsibility of database ledger. The chain code services is a decentralized transactional program running on the validating node. The chain code services use a Docker tool to host the chain code without relying on a particular virtual machine or computer language. The Docker provides a secure, lightweight method to sandbox chain code execution. The environment is a lockdown and a secured container, along with signed base images containing a secure operating system and chain code language. Then comes the application layer. The application layer has a member application partition, blockchain, transactions, and chain code. The Fabric provides different APIs to interact with the membership, blockchain, transaction, and chain code using direct APIs, RESTful APIs, the SDKs, or the command line interface, all of which are available. API can be expanded to different categories and role. So, another could be identities, address, transaction, blockchain, chain code, network storage, or events. This identity could be an enrollment to a certificate or revoking a certificate, whereas address can be to target a source of transaction and to identify where it is. Transactions are nothing but a unit of execution of a ledger. Now, if you want a particular transaction information from the ledger, you can use transaction-based APIs to do that. That is all about the architecture of Hyperledger Fabric. Our next session will be on the components of Hyperledger. Thank you.